Hello, welcome everyone. Glad you could be here again. Today we're talking about chaos engineering and Azure Chaos Studio with our guest René, Casper, and me, Geert. And this half hour we'll just have a brief chat on chaos engineering. I hear it more and more at customers, in the industry. So let's define what's chaos engineering for us and, well, when would you use it? What does it help? So, chaos engineering, it's quite a cool term. What's your definition of what do you understand by chaos engineering?
Yeah, so it's a relatively new discipline, chaos engineering. I think it emerged a few years ago, and it's evolved over the past couple of years. But it revolves around the idea that failures will happen, right? We try to make our systems more and more robust. We try to make them fault-proof. And chaos engineering is literally injecting faults into our system and testing hypotheses, like does it recover like we expect it to do? Does our automatic failover actually take place? Does our auto-scaling kick in? Yeah, basically, is it able to recover from faults? That's what it's about.
Yeah.
Do you have an addition?
Yeah, well, I don't know the exact definition. There are, of course, good definitions all around the internet. But I think that what Casper says, more or less covers the basics. I think it's more, using experiments, so well-defined experiments. So thinking about what you actually expect from your system, and while validating if your system actually does what you expect it to do by introducing chaos on purpose. Yeah. And chaos can be everything. So it can be pulling systems down or introducing latency or, dependent services that are not available or data centers that are out of the air. Yeah. So it can be everything, yeah.
Yeah, so the first thing I always hear when I mention chaos engineering to people, they're like, oh yeah, that's killing servers in production and chaos monkeys. And that's like, that's not what it's about, right? It's about we want to build reliable software that works for everyone. And our solutions are becoming more and more complex. With the cloud now, we have a lot of network communication between all the components. Well, years ago, when everything was on premises, it was all running on the same machine or at least in the same rack, so it was far less failure that could happen. One of the analogies I always like to use, and well, now it's a bit more it's like doing an injection of a little bit of harm. It's like same as taking a vaccine, right? You're injecting a little bit of harm into your body, so your body knows how to react to the actual things that might happen. So you learn from it.
Yeah, and I think that really covers that point of that idea of people that, you just randomly start killing servers and see what happens. That's totally not the point. You will start small, right? It's like you expect that something will work, and then on a small scale you start experimenting if that's really the case. And if that goes, you can expand your radius a little bit, because if you do it on a production system with 10,000 users and your hypothesis is not true, then you will directly have a problem with your business, and that's something that you cannot do. So I think that your analogy is spot on. Like you start small, introducing small experiments, and then expanding the radius and expanding the experiments.
And the idea is always like your hypothesis should be everything will keep running.
Yes.
Right? You never do an experiment like, if I pull the database down, then everything will crash. That's not something you would do with chaos engineering. You only do the experiment when you think, when we remove the database, everything will keep working because we have a caching layer or we do some other fancy stuff. That's the experiment you want to check.
Yeah.
Right? Never have a failing hypothesis, because that's not. Then you have other work to do. Then you have to build a more robust system. And
Yeah, but I think it goes hand in hand, right? Like you're trying to verify your hypothesis. Like, okay, if West Europe becomes unavailable, will all the traffic be routed to North Europe within 5 seconds, for instance? And maybe it's not the case, but you will learn from the experiment and also, make your system more robust by the lessons you learned from the experiment, right? So rather than, that's the beauty of chaos engineering. There's a lot of scenarios that were hard to test in the past. And now there's a lot of tools that make it easier to actually perform these experiments. And now we don't need to wait until it actually happens, until something disastrous happens. We can experiment and see.
It's also a practice where it's being used a lot, like in incident response learning. So if you have new people taking on call, for example, you can just give them a pager and send them off in the weekend. And like, we're going to party. You have to sit at home and wait until stuff happens. Now you can teach those people the incidents by faking them.
Yeah, what usually happens, of course, is that when a company decides to start doing chaos engineering, usually they will all center around a certain day. They will call it game days, for example, where they say, okay, on this day of the week, from 9 to 12, take an extra eye on the alert channel in our Slack, and because we are running chaos experiments, so things might happen. So be aware of that. So that when I don't know, monitoring goes up or spikes or things happen that were not expected, that everybody in their company that actually has a role in these complex systems knows about it, because it's not you doing random experiments and then fix it, because you need other people. So it is also wise to say, well, on this day, the game day, we are doing these experiments. And once you are more mature, like Netflix, and it has been proven that an experiment actually works, you can start automating these experiments so that they can run continuously and everything keeps running.
It's all part of the reducing the blast radius, right? You don't want to break stuff in the end. So if everyone's in the office, it's safer to do things, because you might think that you have a reduced blast radius, but maybe because that server didn't respond well, some other server took over, and that's taking a lot of CPU and then taking down the whole server, all the servers or the Kubernetes cluster or whatever. So then having everyone available is of course a smart thing to do.
No, but I think we are already talking a lot about doing the experiments, but I think it's also good to know like the mechanics of doing chaos engineering, the during and the after phase. And in the before phase, that's also maybe the most important phase. Like how do you design your system? So what do I expect from my system? Do I expect that the database can go down? Do I expect that this external service is always available or not? And how does my actual system respond to that? So how do I make my own system more resilient to all these things that can happen in complex system? And then you move to the during phase, where you say, well, this is the hypothesis. I expect my system to behave X, Y, Z, so that we can still continue our business. And we define experiments there. We know beforehand what are we going to do. We are going to inject latency in this one. We are going to introduce faults.
Then you're already designing the experiment. Let's zoom a bit in the first stage, like before we do actual experiments. What I really like about the pre-phase as well is like having the conversation with everyone. It might be that you have a certain architect or someone else having an idea. Well, if the database is down, then we will our caching layer will just send results when the database is not responding. And if you have a discussion with everyone involved, maybe someone in networking or a developer will say, well, that's not the case. That's not how it really works in the code. And already having that conversation is really powerful and can help you solve certain things that you might think are really reliable but might not be. And from there on, if everyone's on the same page, like this should be able to withstand these and these problems. Then it's also everyone's responsibility, right? It's not but you said it would work and now it's still crashed, right? And then you get a sort of blame game. You want to avoid that, right? As a company, you're all together responsible for building and running the application.
And the other nice thing about the pre-phase is it really forces you to think about what is the steady state for the system. Like how do we see it in the data? What are the characteristics of a steady state? And you also have a conversation starter about that. Which
Yeah, it's good. Like you often say, well, we have these availability, or we have SLAs and those kind of things. But what is the actual current state that we're living in, so we can set these goals, right? That's if you don't know what normal is, how can you check what's not normal?
Yeah. So that is basically the mechanics of that, doing those chaos engineering experiments, starting with hypothesis, setting the baseline. How does my system normally behaves, and then running the experiments and actually look at the monitoring or the output or logging stuff, so that you can actually see. Does my system do what I expect it to do? And if not, go into the root cause of why is that this thing happening.
Mm-hmm. So any more regarding the pre-phase before we do actual?
No, I think that be aware of the blast radius. I think that is one of the most important things. So you can say, well, I can pull the database plug, but what if that goes wrong? Can I go back? Is there an easy way back? Is there a kill switch that you can actually stop the experiment easily? Because, if you have a system existing of, 20 components and you inject failure into one, what will happen to the other 19? And you should have a very good sense of what might happen, and are you able to actually reverse so that blast radius can be minimized? Yeah,
especially when the experiment cascades beyond the reach that you were aiming for, like only the database with a server on top. But maybe because of that, a lot of traffic happens on the network, so really components that are completely separate might break, and that you want to avoid that. So having a kill switch or a abort button is really important in planning those things as well.
I think that people that actually have a good understanding of the system as a whole, if that is possible, but like how should this work? How is this engineered? What is expected of this? So it's not for the faint of heart.
Mm-hmm. And moving to the next part, like designing the actual experiments and executing them. What would you like to explain about that?
Well, some people advocate chaos engineering is always done in production. I also say first start in the acceptance environments, because you want to get a grip of what's going on there before actually moving to production. But what else?
So in production, the most value in the end comes out of production. But you want to learn about doing these experiments as well. Get your confidence on starting them, being able to abort them, all those things, learning about them before you do things in production. Because doing them in production, you do need to have quite some control over your environment. Stopping the environments, not impacting actual users.
Exactly. Yeah, I think that during the experiment, so what I already mentioned before, the hypothesis, the experiments, define them well. And make sure that people are actually aware. So have the monitoring in place, and also know where to look at. Have people stand by, all those things, and have a good logging. So what you also see in the SRE world or with the incident commanders, have a scribe. Have someone doing the communication, have someone doing the logging and writing down the notes, so that you can really focus on the tasks at hand and not doing everything at the same time, because then probably you will find out that you have done great experiments but learned nothing about it because you were too busy with all this stuff going on. Yeah,
and there's a lot of tools, and we'll look into them a bit later on as well with Azure Chaos Studio, but tools are not the only thing that we need to take into account, right? Not all chaos is caused by the actual software. You also have things that might not work in your organization, or things with people. Those are also really important experiments that might be the easiest experiments to start with, because, they will happen to every company regardless of you practice chaos engineering.
Yeah, exactly. Yeah, human chaos. I think things like what happens if you remove the most important person from your team that knows all the the credentials or all the systems or how to log in or where to find the documents or whatever. What if you remove that person? What happens then? That's also introducing chaos and has nothing to do with tools. And I think that is one of my... I'm always looking at process first instead of looking at tools. And the same happened to DevOps. So first it was DevOps as the approach or as the concept. And then all the tool vendors took the term and went along and created DevOps tools, but then we forget the people and the process side. And I think with chaos engineering is exactly the same. There are great vendors of tools that can help you with defining experiments and running experiments and introducing all kinds of chaos into your systems. But they won't help you with the human chaos or designing a good system. And I think that looking at the process as a whole, chaos engineering is far more important than buying any tool that's out there on the market.
I think it's really a part of just resilience engineering, right? Building a stable product, and the people that are involved in building and running the application are just as important. And those are the easiest experiments to start with. Just saying, well, René, you're the go-to guy to always fix stuff in production. Let's just have you on standby, because if the other people can't fix it, we'll have you as a backup. But let's see what the rest of the team will make out of this incident without you. I think that's really good knowledge to have, because you might get sick, you might get injured or whatever. Then all of a sudden, the shit hits the fan, and you want to know what would be the implication if those things happen. And I think we're all consultants who are coming to many companies. There's always those go-to persons that know how to do everything, and they always help fixing all the production incidents, etc. But what if they're on vacation or not able to work?
Exactly.
Yeah. And of course, sooner or later this happens. Everyone goes on vacation, but we don't think of these as chaos experiments. But I think you're right. In a way, they are.
And I think that's also a nice thing. So I don't know how you look at that, but so which companies are actually most suitable for doing chaos engineering? So looking from the approach that we just discussed, I think it's applicable for a lot of companies, especially the soft stuff or the easy stuff or the human stuff. But I don't know how you see that.
I do agree. Like there used to be a big technical effort that people had to put in to actually perform chaos experiments, like setting up the meshes it used to be a lot of efforts, but I think nowadays it's easier than ever, also with Chaos Studio, to perform experiments, and it really helps improving the resilience. And I think this is something that every company wants. So given the relatively small effort to conduct these experiments, I also agree.
Every company that has things that need to be reliable should be doing some kind of things like these, right? So I think chaos engineering really works well in DevOps organizations where you have a team responsible for building and running the application, because then it's really the focus of the team to build a reliable application. If you look a bit more to traditional applications where you have development and operations separately, it's a lot harder to do these kind of experiments, because you always also have to build your application in such a way that allows for experimentation or control of your environment that, well, as a developer is only relevant if you're also responsible for running it. And also have the product owners have that same feel like they're the owner of the full application, not only about the features, because then if you're only focusing on the features, then you would never build more reliability into your application and cater for these experiments and those kind of things.
Yeah, but I think that what you also said in the beginning, that by having the conversation with a different type of people, I think that can also really help in just building better systems.
Yeah.
So by having a discussion with developers and operations, even if it's separated, like what do you expect from the system to happen if this would happen, and asking the same question on the other side, I think that already gives a total different way of looking at a system and designing the system, and maybe also catering for eventual failures of the system. So, yeah, I think the hardest part of the chaos engineering is not in doing the experiments, because there are tools, and if you want to take down a certain network port, there are also easy ways to do that by writing a script or just shutting down a port. But I think that the maturity level of the organization is important when actually designing good, resilient systems, because that is something that it takes a lot of knowledge and skill to create and design a system that is actually resilient. Because you can say, what if I pull down the data center? But can you actually build a system that is good enough to actually fail over when it happens? Because that is not as easy as it sounds. So I think the maturity, maybe not doing the chaos experiments, but building the system to handle those experiments is maybe the hardest part.
Yeah, but that's something that companies have been doing for decades, right? The banks had like failovers for decades. When one data center would go down, they would have some form of failover to the other data center. It might be some manual steps in between, people plugging cables and putting it into some other machine. That could be traditional ways of handling failure, but really building this into your daily flow and making it easier. I think that's the maturity that you're talking about.
Exactly.
And making this easier and easier. That's why I think it really works for DevOps organizations, because then you have a really fast cycle, feedback cycle of, let's design this and let's also see if that actually is working. Because I've seen it happen at so many large enterprises. They build a really robust system with all these failovers, but they're never actually checked if they work. Yeah, on paper they work. But then when stuff happens, always in the weekends, people have to be dialed in, have to drive to the office to fix stuff. No,
but I think,
this is exactly the reason why I think it's interesting for a lot of companies, especially companies that put some effort into building resilience into their application. Even a big company like Netflix, like when they really started using chaos engineering, they found out that they had a lot of improvements to make before actually failovers were successful, and they increased the time of doing a failover by 10 minutes to less than a minute, right? Because they were actually preparing for the chaos by regularly introducing it. And this is a mindset that I think is mostly the mindset that needs to grow at the big companies, right? But you can easily translate it into the stakes involved, right? Like if, these are the list of hypotheses we have about the system, so it should work. Yeah. No, we can actually test it now, and
exactly.
if it doesn't work, well, maybe you lose.
Exactly.
I don't know, like 100,000 euros at Black Friday because your auto scaling doesn't work as expected.
And that's when those tools come in, and I think that is also, that market is also of course now growing, and that is with a reason. I think that the tools are not growing as fast.
So what's your opinion? Can we still, in the modern day and age, can we still do resilience engineering without chaos engineering, or is that?
Well, yeah, as a good consultant, I would always say it depends. But I think that the difference is that, of course, you can still do good resilience engineering. I think the point of chaos engineering is that you actually prove in a simulated environment, or at least controlled environment, that all your design decisions actually make sense and work. And I think that if you have a simple application, which is a web application using a database, for example, you don't need chaos engineering because it's a controlled, you know what can happen. But if you are moving towards more microservices architectures or services that rely on many different moving parts, and especially within the clouds with all the PaaS services that you use, well, if something breaks, it always has a cascading effect. So the firewall is not doing the right thing, so it fills over to another web application that uses a different database, and the database is also slow, and then it happens. And those kinds of scenarios are very hard to design for. And I think that chaos engineering can help there to actually inject those things into multiple components of the system. So I think the answer to the question is, if the systems are becoming a little bit more complex, I think you cannot do a very good job at resiliency. Only based on facts or guesswork.
Yeah, and with the simple systems, you might still do some small experiments or just switching some stuff by hand in an acceptance environment. You might not call it chaos engineering, but it might be like small experiments, which you could tell that that's chaos engineering.
Yeah.
Right? So without making it a real practice within your company.
Yeah.
So looking at the time, let's have a quick look at Azure Chaos Studio. So Azure Chaos Studio is a new tool at Microsoft is still in public preview, and what Azure Chaos Studio is doing is actually helping you execute these experiments based on your infrastructure within Azure. Of course, there's many tools already on the market, right? So Gremlin is a company evolved from Netflix. A lot of people that did the Netflix chaos engineering started the company Gremlin, and they started building tools around that as a SaaS offering. There's a lot of open source tooling as well, Chaos Toolkit, Chaos Mesh, things that you can inject into Kubernetes to do chaos experiments. And those tools work quite well for VMs or basic infrastructure that's cloud agnostic, right? For containers or VMs, that all those tools work quite well. But what's often really hard to do is causing actual failures within the cloud provider, right? Exactly. And so that's what I really liked about the idea from Chaos Studio, is that how do I fail over my database from one region to the other? You can't always simulate things. Mm-hmm. What happens? How do I fake a West Europe failure within Azure? Those are not things that you can script easily, right? You can kill all your your resources, but that's still a different experience than really killing the environment. So Chaos Studio within Azure is not capable of doing all those things yet, so it's really a preview thing right now. So some basic stuff is in there. Let's just have a quick look, and I'll zoom in a bit. So Chaos Studio is not like a resource that you actually have to deploy. It's just already there. And with that, there's only two things you can do. There's a targets area, so all the resources that you own within your subscription or within your resource group or whatever you have permissions to. You can onboard those resources, and currently it's still quite limited the amount of resources that are supported, right? So it's basically VMs and VM skill sets, and on the other hand, Kubernetes clusters and containers, those kind of things. So those are the main components that are supported, and Cosmos DB, which is the first real PaaS service that's supported.
And a network security group.
And a network security group. Yeah. So you can disable some ports and those kind of things.
Yeah.
So it's still quite limited. On the roadmap are things like disabling a region and those kind of things. When those things will be available, I think it will be a lot more useful for us compared to the other tools that are out there in the market. Like Chaos Toolkit, you can do the same things. You can install some agent on a VM, which kills the VM, adds latency, and those kind of things. So first we have the targets, and then we have experiments. We already talked about them. Experiments are like a step-by-step guide of injecting some chaos. So let's, I already quickly created one. So how this looks, you create an experiment, and basically it's just a really simple workflow. So you can create a number of steps. You can give the step a name and a branch, so you can do multiple steps at the same time. And then you inject a certain fault. And the fault, you can either, well, it depends, of course, on the resource that you choose. So let's have a quick look at the list that's in there. You can shut down a VM or a full scale set. You can do a failover of your database. You can do a lot of stuff with chaos mesh, which is a service mesh on AKS. You can cause I/O on that container, or kernel panic, or CPU load, latency, all those kind of things, DNS failures, all kind of things related to the network that you can inject into those containers. Also the same for VMs, pressuring CPU or a disk, or kind of kill services on the VM. And doing some network things like disconnecting the network or adding latency. So you choose either one of those, and you choose the actual instance on which you want to run it, and then you just add them all in an experiment file. And then when you save it, it will just show here as your experiment, and from there on you can start it, and it will just execute your experiment.
Yeah. Mm-hmm. And are those experiments, are those scriptable? Are those ARM based or something?
I think they're last time I looked, they were actually XML based or JSON. I can't remember. I think it was XML before, but it doesn't matter that much. Yeah, it is doable, but it's still it is in preview, so a lot of things might change. One of the things that you need to take care of when you do these kind of experiments, of course, you also have to set up logging and monitoring. Mm-hmm. So knowing what the normal was and comparing that to when your experiment happens, right? So that's not in here. That's stuff you need to do by yourself as well.
Yeah, but I also heard a lot of things about the preview of Load Studio that they are building right into Azure, and I also understood that those teams are working together. So what I hope that they will do in the future is that they combine those efforts and say, well, in the Chaos Studio I define an experiment, and then I will have a lot of load on this part of my infrastructure, so that my monitoring can actually show up with some things, and then actually do the experiment and see the load, because. Yeah, of course, on production you normally have load, but as Casper already mentioned, it's maybe not the first step to actually start testing in production, and then you need something like load on your system. Otherwise, you
it
don't
could
have
also
metrics.
be in a production environment that you have services that are not exposed yet to the outside world, and you have sort of a canary release and do your fake load on that. You want to have synthetic load so you can also compare. Just deploy two services, and on one service you inject some chaos and the other one you don't, so you can compare the actual differences between them.
And there are ways to induce a kind of load testing, of course, in chaos engineering, like by putting high CPU and memory stress on the nodes. But it would be a nice feature.
Yeah, especially when you want to, more looking at experiments targeting the customer. For example, when service X is down, my customers can still buy my products. Then, it's not definitely a CPU or memory thing. Yeah. It's more like, can we still complete the scenario that actually makes money?
Yeah, it doesn't have to be a hard failure, right? You can also have like a small latency on your request in your web shop. By all the requests are a bit slower, and I read somewhere a couple of years ago that if Amazon would, if they had 0.1 or like 2 milliseconds delay, they would lose so many millions of dollars revenue because, well, big numbers times big numbers, that's or small numbers times big numbers is still a big number. So yeah, those kind of effects you also want to be able to measure.
Yeah.
So looking at the time, I think we're already past our half hour for now. Well, hopefully our viewers enjoyed it. We'll be back soon with another topic. So if you have any topic you want to discuss in a group like this, just let me know and we'll schedule something for next month. So see ya, and hopefully till next time.